Next, we're going to look at how we can find these trig ratios. Okay, now, but before we start, one thing I just want to mention here is going to be this. So when we, in trigonometry, the letter of the vertex of the angle is, a lot of the times, it's going to be used to represent the measure of that angle. For example, the sine of angle A, so when we look at, again, the sine of angle A is going to be abbreviated, and we're just going to call it SIN A. So again, we're just going to write this as sine A, or the sine of angle A. Okay, so that's one important thing to just sort of realize how things are going to work. So when we look at this, it says, again, finding trig ratios. So we're supposed to find the sine of J, right? So if we're looking for the sine of J, right, we're going to look right at angle J right here. Okay, so this is the angle that we're actually talking about right here. Okay, so I'm just going to color this in a little bit. Okay, so the sine of J, remember, we have to remember, so ka toa. Okay, so remember, the sine is going to be the opposite over the hypotenuse, the cosine is going to be the adjacent over hypotenuse, and the tangent is going to be the opposite over the adjacent. So when we look at the sine of J, remember, the sine of J is going to be equal to the opposite over the hypotenuse. Okay, so the opposite angle or the opposite side, or the opposite leg, even better, of J is going to be KL. Okay, so we'd say the sine of J is going to be equal to, that's 60, okay, over, and the hypotenuse here is just going to be the hypotenuse of the right triangle. So the side that connects the legs is KJ, and so that's going to be over 61, right? So all we have to do is take 60 divided by 61, and we end up getting 0.049, or that's about equal to 0.05, okay? So that's going to be the sine of J. All right, now let's look at some other ones here, okay? Just a couple more. I'm going to go ahead and erase the green on my triangle here so we can treat each problem a little bit as a unique problem. So next we're looking at the cosine of J. Okay, so we're still looking at this angle J here, so we're still looking in this region or at this vertex, okay? And the cosine is going to be, remember, again, we're going to write down the cosine of J, right? So the cosine of J, again, is going to be the adjacent. So the cosine of J is going to be the adjacent. So I'm going to abbreviate this ADJ over hypotenuse. Okay? So the adjacent side, or the adjacent leg to J is the one that's connected to it, right? So this is going to be the adjacent leg, which is 11, right? So I'm going to say now the cosine of J is going to be equal to, the adjacent side is 11, okay? And the hypotenuse here is still 61. Okay, so 11 over 61, and we can try to, divide that. We'll take 11 divided by 61, and we end up getting, about 0.18. Okay, so that's going to be the cosine of J. Okay, again, it's just like a ratio, right? And then finally, the tangent of K is the last one that we got to do. So I'm going to erase my red here. Okay, we're going to do this one in blue. So now we're talking about angle K, or this right here. Okay. And so the tangent, remember, so I'm going to write the tangent of K is going to be equal to the opposite leg to the adjacent leg. Okay, that's the TOA part. Okay, so now we'll write the tangent of K is going to be equal to, well, the opposite to K, the opposite side, is 11. So that's 11 divided by the adjacent leg, or the one that's connected to K, is KL, which is 60. So 11 over 60, right? So 11 over 60, 11 divided by 60 is going to give us, again, about 0.18. So this is 0.18. Okay? So again, I hope this is helpful. I'm actually going to continue right now and just do a few more examples. Okay? So this video might be a little bit longer than 5 minutes, but that's okay. All right, so now let's go ahead and move to the cosine of A. So again, the cosine, well, I'm just going to maybe abbreviate this again. The cosine of an angle is going to be the adjacent over the hypotenuse, right? Again, I'll write this up at the top again. We're doing so SOHCAHTOA. Okay, and so the adjacent over the hypotenuse here, in this case, is going to be, again, we're looking at angle A, so the adjacent leg to A is this one right here. Okay, so that's 24. So that's 24 over the hypotenuse here is, again, the one that connects the legs, so that's 25. So 24 over 25 gives us 0.96. Okay, so again, simple enough. I think the practice is definitely going to help us here. So I'm going to erase my green and let's do the next one in red. I'm going to scroll down just a little bit here too. Okay, so now we look at tangent, right? So remember, the tangent is going to be the opposite over the adjacent. Okay, so again, we're looking at B now. So the opposite leg to B is the one that is not connected to our vertex of B. So it's going to be this one right here. Okay, so it's going to be equal to 24 over the adjacent leg to B is the one that's connected to B. So it's going to be 7. Right, so 24 over 7. And that is going to give us 3.43 by rounding. So let's say 3.43. Okay, and then finally, we will go ahead and take a look at the sine of B. Okay, so the sine of B, I'll do this one in blue. We're talking about, again, angle B or vertex B right here. Okay, and that is going to be, again, oh heck, another hour of algebra, or SOHCAHTOA. So our sine here is going to be the opposite over the hypotenuse. Okay, so the opposite leg to B here is 24, okay? Sorry, I'll go ahead and write that down. So the opposite leg is 24, and the hypotenuse here is 25, okay? And so we'll get 25 here, and when we divide there, we get, again, 0.96. Okay, so we maybe see some sort of theme here about these two numbers matching, so 0.96 and 0.96, and you can kind of make some guesses as to what's actually happening there. Okay, which is great. Okay, we'll check out some new stuff next.